Today we're working on the 5.6 notes. This is solving quadratic equations by finding square roots. Alright, so the first thing you got to know is that your answers are going to be in radical form. A radical just means it has a square root bracket of it. The properties of square roots, A has to be greater than 0 and B has to be greater than 0. So you have the product property. The product property says that if you have the square root of A times B, you can make it the square root of A times the square root of B. Now what we're going to do is we're going to use that to simplify radicals. Our example of it looks like this. If I have the square root of 8, that's the same as the square root of 4 times 2. Now here's where I use that property. Alright, I changed the 8 to 4 times 2 because 4 is a perfect square. So I do the square root of 4 times the square root of 2, and then I take the square root of 4 and I get 2 root 2. So your answers have to be simplified. That is simplified, and that's how you use the product property. Alright, the quotient property says this: if we have the square root of A over B, we can simply break it up and make it into the square root of A over the square root of B. Alright, how we would use something like that is if I had the square root of 8, let's make that 7. Alright, square root of 7 over 9. Then I would break it up, make it the square root of 7 over the square root of 9, and that would give me the square root of 7 over 3. Alright, so with radicals, you can have a radical in the numerator of the fraction. You can't have one in the denominator, and you cannot have a fraction under a radical. It's not simplified, because that's what we're talking about next. Alright, you can use these properties. Okay, so the properties we're going to use, we got the square root property is simplified if, alright, 1, no perfect square factors are under the radical. Alright, so no perfect square factors are under the radical. Alright, that's why the square root of 8 was not simplified, because 8 has a factor of 4 in it, and 4 is a perfect square. Alright, so you can't have that. That's why 2 root 2 would be the simplified version of the square root of 8. Alright, so that's one. Alright, number two. Number 2 says no fractions are under radicals, and no radicals are in the denominator of a fraction. Alright, so again, no fractions are under a radical, so that's why the square root of 7/9 was not simplified. Alright, and no radicals are in the denominator of the fraction, and that's why we couldn't leave it as the square root of 7 over square root of 9, because the square root of 9 is in the denominator. Alright, so that's why this one is simplified. Okay, we don't have any radicals over the whole fraction. Okay, and there aren't any radicals in the denominator. We can have radicals in the numerator. That's okay. Alright, so that is simplifying radicals. Alright, so I'm going to give you an example of that. Alright, how we simplify radicals. Alright, if I had the square root of 72. Now, one of the things you might want to do to make this easier for you is if you list all of your perfect squares. So what I usually do is I list them top down. So I start with 12 squared, which is 144. And then 11 squared is 121. And then 10 squared is 100. 9 squared is 81. 8 squared is 64. 7 squared is 49. 6 squared is 36. 5 squared is 25. 4 squared is 16. 3 squared is 9. And 2 squared is 4. So these are all our perfect squares. These are the ones we usually work with. All right. So square root of 72. Well, we have to see if there's any perfect square factors. 72 is not one of my perfect squares. So the easiest thing to do is take half of 72. 72 would be 36, and that happens to be a perfect square. So we know that 2 times 36 would give us 72. So this one we would just make into the square root of 36 times 2, which gives us the square root of 36 times the square root of 2. And the square root of 36 is 6, so we get 6 root 2. Okay? And that's how to simplify that one. All right. The next one, square root of 7 times the square root of 35. Well, on this one, what you should notice is we have a square root of 7 here, and that we do have 7 in 35. 7 times 5 is 35. All right. So what I would do is I would make this the square root of 7 times the square root of 7 times 5, which would give us the square root of 7 times the square root of 7 times the square root of 5. All right. And then the square root of 7 times the square root of 7, I would put those together, and that would give me the square root of 49 times the square root of 5. And then the square root of 49 is 7, so I would get 7 root 5. That's probably the easiest way to do that problem. All right, if you notice that if you have something by itself and you know that's not a perfect square and it doesn't have any perfect square factors, see if that number is in there. All right, and then C, for example 1, again, what you recognize, what you want to look here is see if you have a perfect square in the denominator. If you have a perfect square in the denominator, then just work with that. All right, so what we're going to do is we're going to break this up, make it root 11 over root 144, and we can see root 144 is one of our perfect squares. All right, so I got root 11 over 12, and that would be my answer. All right, so that was example 1. All right, example 2. All right, this just talks about rationalizing the denominator, which is what I'm going to show you right now. All right, in example 2. So rationalizing the denominator just means making the denominator into a perfect square. So the 2, all we would do is we would extend this. Now, to make 2 a perfect square, we would multiply it by 2. Now remember, with fractions, whatever you do to the bottom, you have to do the top. So we have to multiply the top by 2. All right, so that's going to give us root 10 over root 4. And then we would break it up, root 10 over root 4. Can't do anything with the square root of 10. And the square root of 4 is 2. And that would be our answer. Square root of 10 over 2. Now, we can't simplify that because this one's under the radical. This one's not. All right? All right, then we have B. We have root 2 over 15. All right. Now, a lot of times rationalizing the denominator means multiplying the denominator by itself. And in this case, that's what we're going to have to do. We're going to have to multiply the 15 by 15 to give us a perfect square. And then that means we're going to multiply the 2 also in the top by 15. All right, so the easiest way to do this problem, all right, is look at this and say 2 times 15 is 30. And then 15 times 15 is 15 squared. All right, you don't even have to multiply it out. So now we have root 30 over the square root of 15 squared, and the square and the square root cancel each other out. So we get root 30 over 15. All right, and that would be our simplified answer. All right. So that was, again, rationalizing the denominator. And you have to do that when you have a fraction underneath of a radical. All right, so there's a checkpoint for you to do. All right, what I want you to do is I want you to do that on your own. All right, and then I'll come back and I'll give you the answers for that later on. All right, but I'm going to go to example 3. So if you want, you can pause the video and then you can do that. And then you can replay it to do example 3. All right, so real quick, example 3 looks like this. All right, so what I want to do is this. I want to forget that this is x squared for right now. I just want to act like this says x plus 1 equals 13, which we've done that before. So all we would do is subtract 1, and that gives us x squared equals 12. All right, so the new step here would be, now we're going to square root and square root, and then whenever we have an x squared, square root it, we have to put plus or minus on the other side. So now we get x equals plus or minus. Now we got to break this 12 down. So the perfect square factor that's in 12 is 4. So we would make this into 4 times 3, which gives us x equals plus or minus root 4 times root 3. And then we get x equals plus or minus square root of 4 is 2. So we get 2 root 3. All right. That's that first one. All right. And then the second one. Again, we're going to just act like that's an x. So we're going to subtract 2. Subtract 2. Gives us x squared equals 24. All right. And then we're going to square root, and plus minus. All right, so now we got x equals plus or minus. Now we got to break this down. All right, and a perfect square factor that's in 24 is 4. So we're going to make this into 4, and I always write my perfect square first, times 6. So again, we break it up. X equals plus or minus root 4 times root 6. X equals plus or minus square root of 4 is 2. So I get 2 root 6. All right. So you have these checkpoints to do. So you have the first set of checkpoints to do, and then the second set of checkpoints to do. All right. And then I want to finish this note off just by doing this word problem. Actually, I'll forget the word problem for right now. I'll bring that back to you when I show you the other ones. All right. So we'll stop right there. I will give you a homework assignment too. All right, but I'll do it later on.